In 12.5, we are going to basically review every single thing we've done, and we're going to add one element to it. So in 12.1, we learned how to solve by the square root method. In 12.2, we also did factoring in 12.1. We also, in 12.2, we learned completing the square. In 12.3, we learned the quadratic formula. And up until now, or up until section 4, we said that if you had the square root of a negative number, that was no real solution. What we want you to do now that you know what a complex number is we want you to solve anything that is imaginary. So when you are working out problems, if you get an imaginary solution, we want you to figure out what those are. Meaning, normally we told you to stop. If you had, let's say, negative 2 plus or minus the square root of negative 4. What we want you to do now is you're going to go, oh, I know how to handle this negative, the square root of a negative. You'll pull out an I. And you know the square root of 4 is 2. So you would put your final answer as negative 2 plus or minus 2i. That's what we're going to be doing with some of our problems. There'll be some i's for the imaginary solutions. A couple things that I wrote down in your notes. Number 2 in your packet is a typo. If you look at number 2, it's not equal to anything. Every other problem is an equation except for number 2. So when you're looking at number 2, you can't solve it the way it is written. So I'm just going to let you guys skip number 2. If you can just skip that one. Okay? The only way I'll fix it on the packet. That way next year it's actually fixed, but it needs to be equal to something in order for you to be able to solve it. Because it's just an expression, you're not able to solve it. And then there are going to be several problems at the end of section 5. So the majority of the problems will be review questions. The only thing that is new deals with this cyclical pattern of I. This is a long word for cycle. There's a pattern to how I simplifies. I is the square root of negative 1. The square root of negative 1 always simplifies to I. I squared always simplifies to negative 1. That's the definition of what the complex number I is. But if you had I to the third, what that would be is I squared times I, because you would add the exponents, and I squared is negative 1, and I is the square root of negative 1. So if you were to think about that, that would simplify to negative I. It goes I, negative 1, negative I, and then I to the fourth is the same thing as I squared times I squared, which is the negative 1 times negative 1, which simplifies to positive 1. If you were to think about that, I to the fifth is the same thing as I to the fourth times I. I to the fourth is the same thing as 1. 1 times I simplifies to I. It starts over. If I were to think about I to the sixth, that's the same thing as, let's say, I to the fourth times I squared. I know what I to the fourth is. It's 1. 1 times I squared, 1 times negative 1 is negative 1. What I want you to notice is I don't even have to start solving these things, and I can start seeing a pattern here. I, negative 1. The next one is negative I. The next one is positive 1. It goes in a pattern. I to the ninth is going to be the same as I to the fifth. I is to the ninth is the same. I can add 4 to that. It's same as I to the 13th. I can add 4 to this, and I know that that's the same as I to the 12th. Is the same as this row. So if I know what the remainder is when you divide by 4, you're going to know what this simplifies to. And you're going to be asked questions that look like that when you get to, let's say, number 20. Okay? So the rest of these things are examples. If you would like to do these as the first questions in your homework, you're welcome to write them down. I'm going to do 2 examples for you. Number 4, solve each quadratic using square root, factoring, completing the square, or quadratic formula. Be sure to give all solutions, including complex solutions. You have a choice. You can factor this, but because there's no b value, I think what I'm going to do here is divide by -4 and divide by -4. There's multiple ways to do this, but this is just the way I'm going to choose to do it this time. So I have x squared is equal to 49 over -4. And then what I'm going to do is I'm going to square root these. And I'm square rooting both of them. This is the same thing as the absolute value of x. Remember why I do that. I know what the square root of 49 is. The square root of 49 is 7. And the square root of -4, that square root goes to the top and to the bottom. I can't do because it has an imaginary solution. So I need to pull out the I right there. And then I can do the square root of 4. The square root of 4 is then 2. So what I have here is 7 over 2i equals the absolute value of x, but I need to pull that out. And so x is going to equal plus or minus 7 over 2i. Can I leave my answer that way? No. You have a square root in the denominator. You have to rationalize. So just like before, if you have an I in the denominator, you need to multiply by something. It's a monomial. You multiply by I over I. Technically, you're multiplying by 1. What this does is the plus or minus stays there. The numerator is 7i. Your denominator becomes 2i squared, and I squared simplifies. I squared becomes something, and then you multiply it by 2. That means your denominator is now going to be what value? Now watch this. Some people will get confused by this. You're going to have plus 7i over -2 or minus 7i over -2. These two things really don't matter when you have a plus or a minus. If you think about the minus a negative, that would be a positive value. If you think about adding the negative, that would be the positive value. So what my final answer will be is plus or minus 7i over 2. Some people would ask me, Mr. Brown, where does that negative go? The -2. Because you already have the plus or minus sign, we're thinking about doing adding the negative, there's our negative value, and subtracting the positive. Really, it's already incorporated in that plus or minus. We don't need to deal with it too much as long as we have that plus or minus there. It has imaginary solutions. Lastly, number 20. I to the 13th times I to the 17th. We have two bases that are the same. So the first thing that I would do is I would follow my shortcut rules and I would add those exponents. 13 and 17 is, I believe, the 30th power. Yeah? I to the 30th. Well, that simplifies further using that pattern. And you could go up here and look for the pattern and calculate it all the way out. But what I do is I divide the exponent by 4 and figure out the remainder. So what I'm going to do is I'm going to go off to the side of my work and do 30 divided by 4 to see how many of these patterns go in. 4 goes into 37 times, and my remainder is 2. So mathematically, I want you to know that this is the same thing as I to the 4th to the 7th times I squared. This part here doesn't matter. This doesn't matter. Why? Because I to the 4th simplifies according to our pattern. It's always going to be 1. Think of it as I squared times I squared. Negative 1 times negative 1. So this is 1 to the 7th power. I squared simplifies as well. You should know what I squared is simplifies too. If you need to go to your pattern, look at your pattern, but eventually you're going to memorize it. I squared simplifies to what value? And that is your answer for number 20. That is it for your notes.